Algebra 1, Unit 1, Expressions, Equations, and Functions. Today we are going to learn the second lesson, Order of Operations. After completing this lesson, you will be able to use the order of operations to simplify algebraic and numerical expressions. When you are summing a list of numbers like this, the order in which you add them does not matter. However, it is not true for other operations like division and subtraction. For example, if you want to simplify this numerical expression, 2 plus 5, negative 16, negative 8. The right way of simplifying this numerical expression is from left to right. Therefore, we add 2 plus 5, 7, minus 16, minus 8. The next step would be 7 minus 16, which is negative 9, minus 8. That is equal to negative 17. But the wrong way of doing this problem is grouping the last two numbers, 16 minus 8, which is 8. Therefore, 2 plus 5 minus 8. 2 plus 5 is 7 minus 8, which is negative 1. This is the wrong way of simplifying this numerical expression. For example, 2 times 5 minus 16 divided by 8. If we start from left to right, which is 10 minus 16 divided by 8, 10 minus 16 is negative 6 divided by 8, which is negative 3 by 4, which is wrong again. Or we don't simplify numerical expressions always from left to right, but we have to follow certain order. That we call order of operations. In order of operations, there are 4 steps. The first step is evaluate expressions inside the grouping symbols. Grouping symbols include parentheses, brackets, and braces. If any expression contains more than one set of grouping symbols, evaluate the expression from the innermost set first. Step 2. Evaluate powers. If there are any exponents in the numerical expression, we have to simplify them in the second step. And step 3 would be multiply and divide from left to right, and step 4 is add and subtract from left to right. There are different acronyms used to remember this order. We use PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, subtraction. Please excuse my dear Aunt Sophie. The first letter of these words can help you remember the order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. Now let us say some examples. Example 1. 15 minus 2 times 3 plus 1. We use PEMDAS, order of operations. Since there are no parentheses, no exponents, we skip the first 2 steps, and now we will see multiplication. 2 times 3, which is 6. Therefore, 15 minus 6 plus 1. And there is no division, then we see the last step, addition and subtraction, but we follow the order from left to right. 15 minus 6 is 9 plus 1, which is 10. Example 2. 48 divided by 4 squared plus 3 over 5. We see the order of operations. Since there are no parentheses, we skip the first step, but there is an exponent 4 squared. 48 divided by 4 squared, which is 16 plus 3 by 5. And step 3 is multiplication and division. We have a division here, 48 divided by 16, which is 3 plus 3 over 5. Now 3 plus 3 over 5 can be simplified in two different ways. One is find the LCM and make a common denominator and add the numerators. Then we get 18 over 5. Otherwise, simply write 3 plus 3 over 5 as 3/3. Example 3. 5.4 minus 3 squared plus 6.2. We follow the order of operations. Since there is no parenthesis, we skip the first step. There is an exponent 3 squared. We simplify it first. 5.4 minus 3 squared is 9 plus 6.2. We add 5 plus 4 and 6 plus 2 first and subtract 9 from the result, which is 11.6 negative 9, which is 2.6. Example 4. This expression contains more than one grouping symbols. Therefore, evaluate from the innermost set first. In this question, 4 plus 1 is the innermost set, and then we multiply the result by negative 2, and we follow the order of operations. 4 plus 1, which is 5. Now negative 20 divided by negative 10, which is 2. Example 5. 4 squared times x plus 3 for x is negative 2. This is not a numerical expression. This is an algebraic expression because there is a variable x. That's why the question says, evaluate the expression for the given value of x. If you substitute x is negative 2 for x, then it will become a numerical expression. Before we use order of operations, first we substitute x is negative 2 for x. X value is negative 2. Replace x by negative 2. Now this looks like numerical expression. Therefore, we follow the order of operations. And then exponent 4 squared is 16 times 1, which is 16. Example 6. Again, another algebraic expression. Before we use order of operations, first we substitute x is negative 2 in the algebraic expression. We have 14 plus 2 squared divided by 4. Now this is numerical expression. We use the order of operations PEMDAS. Since there is no parenthesis, we skip the first step. We have exponent 2 squared, which is 4. 14 plus 4 divided by 4. Now we will do division. 4 divided by 4, which is 1. 14 plus 1 is 15. Example 7. Another algebraic expression. Substitute x is 6. Now we have numerical expression. We follow the order of operations. Since there are two parentheses, we simplify them separately and then we divide the result. 6 times 2 squared is 4. 24 divided by 8 is 3. We have learned grouping symbols, parentheses, brackets, and braces. In order of operations, we simplify the expressions within the grouping symbols first. Fraction bars, radical symbols, and absolute symbols can also be used as grouping symbols. Remember that a fraction bar indicates division. Let us see some more examples with these grouping symbols. Example 8. 2 times negative 4 plus 22 divided by 4 squared minus 9. The fraction bar acts as a grouping symbol. We simplify the numerator and denominator separately before dividing. We use order of operations. 2 times negative 4 is negative 8 plus 22 over 4 squared is 16 minus 9. We simplify numerator and denominator separately. Negative 8 plus 22, which is 14, over 16 minus 9 is 7, which is 2. Example 9. We have another fraction bar. So this fraction bar acts as grouping symbol. We simplify numerator and denominator separately and then divide. 5 plus 2 times negative 8 divided by negative 2 cubed, negative 3. Here, negative 2 cubed is a power, which means negative 2 times negative 2 times negative 2, which is negative 8. We use this result. 5 minus 16, negative 2 cubed is negative 8, negative 3, which is negative 11 over negative 11, which is 1. Example 10. 4 minus 7 is an absolute value symbol. This acts as grouping symbol. Therefore, we simplify 4 minus 7 first. 4 minus 7 is negative 3. The absolute value means distance, so it will be a positive value. Negative 3 becomes 3. 3 squared is 9. 9 divided by negative 3, which is negative 3. We'll see one last example. Example 11. Here, radical symbol or square root is also acts as grouping symbol. Square root 39 plus 10, which is square root 49. Square root 49 is a perfect square, which is equal to 7. 3 times 7 is 21. Congratulations! Now you have learned how to use order of operations to simplify numerical and algebraic expressions.